We're working on an automated bag valve mask device that is going to provide the ability to mechanically stimulate these readily available bag valve masks, which are available in most hospitals in wide supply. And this device will mechanically compress this to reduce the burden on human operators who might have to compress this bag for hours at a time. This is not a high-tech device that requires a lung doctor or pulmonologist to set. This is a device that could reduce the load on existing ventilators to basically help people who are in respiratory distress, but not at a critical case.
When you mechanize that motion, you put sensors along that mimic the respiratory cycle. That turns it into something very unique, and you get essentially all of the functionality of a full ventilator, especially with sensors and safeguards, which is what we've done at Rice. Now, another beautiful part of this relationship between medical doctors and engineers at Rice University is that we have end-to-end clinician input. From day one, the project was clinician-led. At all critical engineering touch points, there was clinical input, and the final product and the final prototypes are going to be used by people like me in the emergency room and the intensive care units where people are actually getting intubated. I do the intubations myself. I know exactly what I need for that. And this device fits into that family very nicely and flows very well too.
Every kind of ventilator right now is in short supply just due to the needs of severe coronavirus patients. And so from my perspective as a robotics guy, it's just a robot that squeezes something. So it's super controllable. If we build it correctly, we can have really good control and fidelity of how we actually provide air to somebody. Similar to a real ventilator, not quite the same. Those things cost like 10 grand. The idea is roughly the same. We kind of apply pressure through someone's airway, but we're using off-the-shelf components.
I don't think we have anything that large, but we can order it, not a big deal. The biggest challenge we have is what parts do we have available to us. So typically a team will have months to do this. They'll order parts, they'll design for a week or two, order the parts to come in maybe a week later, and then they keep reiterating. We have maybe hours in some cases, so we're trying to recreate parts, but probably the other biggest challenge would be this has to be openly, readily available things. That's the whole idea behind this whole concept. So solving a problem that a multi-$1,000 ventilator can do, but doing it in less than $300 is a bit of a challenge, especially at times like this when we don't have the resources that even anybody would have normally.
It's been really helpful with the state of things to have this distraction because it's keeping us busy, and it's also keeping us very focused so that we can help in some way. We all wanted to help, we weren't sure how we could, and when this project came our way, it was a way that we were able to help using the resources that the Oshman Engineering Design Kitchen has.
Yeah, we were going to make an adapter to go in between those two.
In between, and this sizer, see how this thing goes into this? Yeah. This device is hospital grade, and you'll see a lot of Me Too things out there. I want people to know that when Rice and teams of doctors come together to build things, they don't just build bare bones versions. They build versions that are high grade, high quality, and trustworthy. And whatever you see come out, you can trust that product from Rice University, I think. And that's why I'm really proud of this partnership, because over the last decade, working with the Rice folks, we have seen that. We have engineered a portfolio of devices for low resource settings across the world, and it's really made a difference across many people's lives. And it's sort of far-flung across the world. People don't know that these devices came from Rice partnerships, which is really lovely to know, and we can keep pushing that forward.